Okay, so now we're on the back here for part 2, and we're going to do some examples where we're going to divide by a binomial, and to do this, let's use synthetic division. Now the thing about synthetic division, first of all, we want this to be a 1x when we're doing it. If this was 3x, you'd have to go through a whole different process. You could use synthetic division, but it would be a little bit more work. The other thing you can't use this for if this was an x squared or more than that. So it's only for a binomial factor, for a linear factor, so x and then some kind of constant. Now if this is x minus 1, then that means the number we're actually going to be substituting is 1. Then I'm going to take all my coefficients, so 1x to the third, 5x squared, negative 6x minus 2. So the process again, the first number comes down, so we just bring the 1 down, and then we multiply that by this number in the corner. So 1 times 1 is 1. Now we're going to add. 5 plus 1 is 6. 6 times 1 is 6. Negative 6 plus 6 is 0. 0 times 1 is 0. And negative 2 plus 0 is negative 2. So I make another little kind of corner there. That's your remainder. Okay, so the solution, we've got the depressed polynomial equation. This is the constant. This is the x. This is the x squared. So we have x squared plus 6x. Now I'm not going to say plus 0. The remainder, it's not minus 2, it's minus 2 over, and then it's the original factor, which was x minus 1. Okay, I say factor, it's not really a factor because it doesn't divide in perfectly. I don't get a 0 here. But the original divisor, okay, I write that as a fraction at the end. Okay, let's do number 5. And go ahead and try this. Pause it, try it, see if you can get the answer, and then come back on and see if we get the same thing. So x minus 3, that means our number is 3. 3x to the third minus 4x squared minus 13x minus 6. Okay, so again the process, 3 comes down, 3 times 3 is 9, negative 4 plus 9 is 5, 5 times 3 is 15, negative 13 plus 15 is 2, 2 times 3 is 6, negative 6 plus 6 is 0. If your remainder is 0, then what that means is that x minus 3 is a factor. X minus 3 is a factor. It divides in perfectly. Now that also means that if I was setting this equal to 0, that's a factor. That means that x equals 3 is a solution, or a 0. So I actually have a solution to this right here. Okay, now here's the thing. If I were to write this out, what's left over after the division is the constant is 2, 5x, 3x squared. 3x squared plus 5x plus 2 is still there. Now that's also a factor. That also divides into this. So that's also a factor. The question is, can we break that down even further? Can we factor this? This is a trinomial. It's a quadratic. Can we factor that? Well, we could try to factor by grouping because that's a 3x squared. So I do 3 times 2 on the side, which is 6. So what multiplies to 6 and adds up to 5, which is the middle term? The answer would be 2 and 3. So I've got 3x squared plus, I'll write it as 3x, and then plus 2x plus 2. We can factor by grouping. We can factor out the 3x from both of those, which leaves us with x plus 1. And then here we can factor out a 2, which leaves us x plus 1. So then both of these have x plus 1. So x plus 1 times 3x plus 2. Again, if we were going to solve this, we could set that equal to 0, and then take each factor, set it equal to 0 to solve, and we would get x equals negative 1. Now here I would subtract the 2 and then divide by 3. So these would be solutions as well. So what you're going to see is that we can actually solve these equations. If you want to think of this as an equation, we can use synthetic division to break it down and then possibly factor at the end to finish it off. Okay, so these would be the solutions. Now, the actual answer to this, just the division part, is 3x squared plus 5x plus 2. Okay, but if we were solving it, then we could continue on with this. All right, let's do 6. X to the third minus 8 divided by x minus 2. Okay, now if it's x minus 2, then that means our number in the corner is positive 2. It's the opposite of what you see. X to the third, so that's 1x to the third. Now there's no x squared, so I have to put 0 for x squared. I have to hold that place. 0x, negative 8 is the constant. Okay, so you have to put the zeros in there. The 1 comes down. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 4 times 2 is 8. Negative 8 plus 8 is 0. Now again, what that tells you is that x minus 2 is a factor. That means that 2 is a solution. It's a 0. Now, what's left here is x squared plus 2x plus 4. So that's the answer that we get from the division. Now, you might ask yourself, can you factor that? Can you think of two numbers that multiply to 4 and add up to 2? And the answer to that is no. Nothing is going to work for that. 1 and 4 doesn't work. 2 and 2 doesn't work. So we can't factor this anymore. If you wanted to solve, so if you wanted to solve it, you would have to solve it, set this equal to 0. Since you can't factor it, you can try a quadratic formula. Okay, we're not going to go through the formula, but you could do that if you wanted. For number 7, last one, show that x minus 1 and x minus 3 are factors of f of x equals x to the fourth minus 10x to the third plus 35x squared minus 50x plus 24. Okay, there's a lot going on there. Then factor the second polynomial completely over the integers. So you can start with either one of these factors. Let's start with x minus 1. Also, if this was x plus 1, then your corner number would be negative. It's just the opposite of what you see. So they're already telling us these are factors. They're asking us to show that that's actually going to be true. So if x minus 1 is the factor, then the 0 would be positive 1. Now we have 1x to the fourth, negative 10x to the third, 35x squared, minus 50x, plus 24. A lot of stuff going on. Okay, so I'm going to go through this process. I'm going to go through kind of fast here. After you do this a few times, it becomes pretty easy. And when I add at the end, okay, I get a 0. So is x minus 1 a factor? Yes, it is. Because my remainder is 0, that means x minus 1 divides perfectly into this. Now to check that x minus 3 is a factor, I'm going to continue. I could do it again for the original polynomial. However, at the bottom, okay, at the bottom of this, x minus 1 is a factor. Okay, I know that. Now, at this point, what's left would be, let's see, constant x, x squared. This would be x to the third minus 9x squared plus 26x minus 24. If anything else is a factor of this polynomial, it would have to go into this one. It wouldn't go into x minus 1. It would have to go into whatever's left over. So what I'm going to do is when I test this second factor, x minus 3, okay, so 3 is in the corner now, I'm going to use the depressed polynomial equation to do it. 1 minus 9, 26, negative 24. The reason I'm doing it is because it's shorter. I've already broken it down from an x to the fourth to an x to the third. So this will go a little bit faster. So I'm going to repeat the process. So 1, 3, negative 6, negative 18, 8, 24, 0. So what that does, that verifies that 3 would be a solution, that x minus 3 would be a factor. Now, what's left, this is x squared minus 6x plus 8. The question is, does that factor? And actually it does. It would be x minus 4 times x minus 2. So this is what we call completely factored. The original polynomial, which was x to the 4th minus 10x to the 3rd plus 35x squared minus 50x plus 24, is equal to this. These are all the factors broken down. And that is the end of the notes.